So let's go through the solutions of the homework questions. On page 260, you had questions 13 and 14. So let's take a quick look now at question 13. You're asked to draw a sketch, and remember sketch just means super fast, of each of these functions, and we don't need to find the turning points. So what we need to find is the roots where it intersects the x-axis and the y-intercept where it intersects the y-axis. So for number one, it's going to intersect the x-axis at x equals 0, x equals 1, and x equals 3. So I'm just using the three factors that I'm given there. And because it goes through x at 0, we also know that the y-intercept will be at 0. We also know that the x's, when we multiply them out, the x cubed will be positive, which means that it's this shape. It ends pointing up. So positive talks about end pointing up, negative ending pointing down. Drawing a sketch then, a very, very quick sketch of this, and we don't even need to label much on my y-axis. Don't need to put a scale on my y-axis because it's going to go through 0, 0. On the x-axis, I do want to fill in 1, 2, 3, and the important points are the x and the y-intercept there, the x-intercept there, and the x-intercept there. Now, because it ends pointing up, I know it has to come through here. So this is the kind of shape that I'm going to have. And I don't know those values. I don't know how high up it goes or how far down it goes. So that's what I'm looking for, just to show that shape. So the points of intersection and the shape is what we're looking for in these questions. Part 2 then, my roots are x equals 2, x equals -3, and x equals a half. Now that last one there, we're setting 2x minus 1 equal to 0. So 2x is equal to 1 and x is equal to a half. If you need to work it out, then you can do that. My y-intercept is when x is equal to 0, so it's -2 by a +3 by -1, and that gives us +6, so y is equal to 6. And again, the x values will be positive, so I'm going to have this shape pointing up at the end. Okay, so let's fill in those 4 points and draw in the shape. We need to go up as far as 6 on the y-axis. And I'm not even using a ruler for a sketch, and that's fine. I mean, it's not great if you're in a test. I'd hope you'd use a ruler, to be honest. But it's fine for homework. We need to go back as far as -3. I should be careful there. So let's call that -2. -1, I'm going every 2 boxes. -3, 1, 2. I actually needed more space on the other side, not to worry. 1, 2, 3, 4, 5, 6. 2, 4, 6 like that. And we'll fill in the important points. We had x equals 2, x equals a half, and x equals -3. And yeah, we had y equals 6, and we know it's going to be this shape. So it will come up here, down through there, and turn around and end pointing up like that. You don't have to put an arrow to show it pointing up at the end. I just find it helps reaffirm the shape when I put in the arrow at the end. It reminds me of which direction I'm going. Part 3 then, now look at this, we have a minus outside, okay? So when I multiply those x's together, the roots and the y-intercept and everything will still be the same, but when I multiply those things together, I'm going to get a minus x cubed. So I will have a shape that starts up and finishes pointing down. So the negative part there means. Right, my roots will be at x equals 1, at x equals -2, and at x equals 4, and my y-intercept will be, now the minus here does count, minus minus 1, I'm just putting all the x's to 0, so they're disappearing, plus 2, and minus 4. So we get minus 8, positive 8, minus 8. So y is negative 8 there. And those are my 3 x values. So I need to go down on my y-axis as far as minus 8, and I need to go between minus 2 and 4 on my x-axis. I don't need to give a whole lot of space above the y-axis in this case. Y and x, 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4, 1, 2, 3, minus 4, 5, 6, 7, minus 8. You don't even have to put in every single number. Let's fill in the important numbers. We had x equals 1, x equals minus 2, x equals 4, and y equals minus 8. So this time I'm going to end up pointing down. And in fact, it's the only shape that makes sense that will go through all of these points. So I start up, actually should turn before then, and I finish pointing down. Okay, and it's fine, if you've got a little bit of a mistake, just rub it out with your rubber afterwards. So I knew it should turn before this point because it wouldn't be a symmetrical turn if I turned at that point, but it's fine. They're not really looking for those details. They just want the basic shape and the 4 points. Now the final one here, a little bit difficult. My x cubed is positive, so I will end finishing up, but I have this kind of strange thing that I have to solve. So let's do the solution of it first before we can sketch it. We have x cubed minus 9x, so the first thing to do is factorize out our common x. The x has gone there, and then we have the difference of 2 squares here, so we've got x plus 3, x minus 3. So they made us factorize it, meaning that my roots will be x equals 0, x equals 3, and x equals minus 3. Minus 3, doesn't matter which order you put them in. And when x is equal to 0, y must also be equal to 0. So this one's going to go through the origin. And when I draw a sketch of it, I need to go between 3 and minus 3. X, y, 1, 2, 3, 1, 2, 3, and we don't care about the y scale at all because the y-intercept is at 0, 0, 0, and this one is perfectly symmetrical, and we know that it ends pointing up. So up and down like that. Okay, hopefully you're all feeling good enough about sketching the graphs of cubics. It would be very rare, especially at higher level, for you to be asked to draw the graph of a cubic. Draw meaning putting in full detail. So most of the time this would be a 5-mark question, and that's what you'd be expected to do. Okay, let's look at question 14, where they're showing us the graphs of 3 different cubic equations, and they ask us which graph represents the function in which the coefficient of x cubed is negative, the one that finishes pointing down, so graph B. Which graph has only one real root, so it means it crosses the x-axis one time for this equation. And let's see, this crosses the x-axis twice, this crosses the x-axis twice, so only this one crosses the x-axis only once. So we've got complex roots up here, and that means graph C. Which graph is, now you may not have done these parts yet, but let's see if we can figure it out anyway. Which graph is positive and decreasing means it's going downhill. The slope is negative when x is between 1 and 2.4. So not this one, between 1 and 2.4, this one is increasing. when x is between 1 and 2.4? There we go, look, it's decreasing. We'll do this a bit more in calculus as well, so don't worry if you couldn't answer these parts. So graph B. So between 1 and 2.4, this one is increasing. My graph is going up. So graph B is the only one that makes sense there. Which graph is negative and decreasing when x is bigger than 2.4? So again, look at these ones. When x is bigger than 2.4, it's still going up. When x is bigger than 2.4, it's below the line. That's the negative part there. And it's still decreasing. So it's graph B again. And this one, greater than 2.4, it's still going up. So it's still increasing. So graph B was the answer to the last two parts there. But don't worry too much about these ones. We'll be going over that idea again when we do differential calculus. So functions will be coming up again when we do calculus. Okay, thank you.